share my screen first. Um, Let me share my screen. Okay. So I hope so. Does anyone has like have problem with installing root or uproot or anything else?
Yes, sir.
Uh,
I have
so
issue.
you cannot install, right?
Yes, I
So
tried to. I am using Mac OS, and I went to the site and tried to install it, but it's for some reason it's not installing.
okay, so you have a problem. Anyone else has a problem? Uproot is not installed. So are you using? So Niraj is saying uproot root is installed, but uproot is not. So did you install it by like pip or conda?
I installed it using that wget command.
Wget command, right? So you can actually install it from the source. In your case, I have never used Mac, so I cannot help you in this regard. But what I understand is you can always like build it from the source and then install it.
Sir, I installed uproot, but I don't know how to check if it is installed or not.
So that test I have. Let me go through it. Uh, Let me go through it. So there are basically let me like briefly go through it. I will not be able to like I don't have much time to show you how to install in each individual options. So there are like 5 options for the Linux system that I like sent out. Option 1 is for those who uses Debian or Ubuntu, where you have apt repository for installation. Right. So first of all, you need some like this prerequisites. You have to have a C++ compiler and Python and developmental version of Python, and you also have to like install pip Python pip for handling and managing the Python packages, and CMake and Git. And if you are using Conda, so Conda, if you are using Conda environment, then you need to install Conda separately. Okay. So now for the Ubuntu and Debian users, what you for the prerequisite, you have to like install the all these build essentials, Python 3, Python developmental version of Python, and pip 3, Python 3 pip. So if these are already installed, you don't need to do it. But for installation of root, so this will be a system-wide installation. It will be installed in your root path, so you can follow this command. But if you are not using if your system is not Ubuntu or Debian, where you don't have apt repository, if you have DNF or yum repository, so you can install it by this. So first command is the prerequisite. If you already have a Python working version of Python and CMake and Git, then you don't need to install these things. But root can be installed via sudo dnf install root. Okay, so this will also be again a system-wide installation. But if you want to install it in your local directory or home directory, then there are like 2 ways you can do. One way would be like compile it from the source. So what you have to do, you have to like basically download the source file. Okay. For example, if you want to use it for let's say, so if you want to install it uh, 13.4 34.08 version, then you have to download it. So if your wget command is not working, you can just go to the website. Let me show you uh, this root. Okay, and then if you click on install root, it will show you that how to install root, and here you can see the download the release option. I hope you can see my screen. Okay? So download the release. If you click on it, then you will see that what are the versions available. Okay, so there are like all versions those are available for root. But I would recommend to install above 6.26. Okay. And so then you choose your version, preferred version, and click on it. Right? Then you will go to another page where there are options for binary distribution. So that is the option 4 that I was talking. I sent out in the instruction sheet, and the option 3 that I am discussing now is the source distribution. You can go and you can basically download it. Okay, so if you click on it, it will it will be downloaded. Okay. So if your wget is not working, that's fine. You can basically download it. Okay. And then go to the directory where it is downloaded, and then you enter it. You can enter it by like mouse also, or you can enter it from the terminal by this command. Okay. So for example, if I can show you that I have this packages. So I have all this downloaded version of different packages. So root, for example, 6.2.28.12, the source version. Then if I right click on it, then you can extract it. So it will extract it to a folder, okay, like this. Then you go inside that folder. Uh, so you don't need to go inside the folder. So you can check that this has been extracted. Okay. Once that is done, you create a different folder. Okay. So that folder you leave out. You create a different folder. Let's say make directory. Sorry, this is the command for make directory, that you can do it by mouse also. And then you go inside this build directory. Okay, so this was a mistake, I think. Then within from this directory, you cmake it. Cmake, then uh, give the path to the extracted directory. So if so, relative path is also fine. Then where you want to install it, that you have to specify. Then for our case, we need Python and Roofit and some other for visualization, GUI support. We need S11 also. So these are the options. We need to keep these on, and you can actually CMake it. Once you do it, then it will create relevant directories and all these things. And then you can make will basically compile the things, and make install will install your directory to the path that you have given here. Okay. So that's the this part actually takes a little bit of time, this option, building it from the source. But ideally this should work in any system, like in Mac OS or in the Linux system. These commands might be slightly different for Mac OS, but it should work. And for the compile, so this is done, and the option 4 is the easiest option. Okay, so what you can do, you first have to check what is your OS, what is your architecture, what is your GCC version that you have in the system. For example, so these three can be checked by these three commands. Okay, so let me show you how you can check this. So if you see that OS release, so then you can see that my version is Debian. Okay. And then the architecture, okay, so it is 64-bit architecture. And then GCC version that you can check is 12.2. Okay, so these three you note down and remember, and then you basically go to the release version and check that whether that exists. So for example, Debian 12 86 12.2 exists. So I just basically have to download it. Okay, and so download can be done by this directly. Okay, for example, I can download it. Okay. And then I can, but so this is available for limited OS system and architecture and GCC version. So This is the easiest version, but you have to basically comply with these three things. Then only it will work. Otherwise, it will not work. So this is easiest, but you have to have this particular setup. Those are available. So that's the thing. And once you um, download it, you can extract it like before, either uh, either by going to the directory and right clicking on it and extract, or from the command line with tar -xzf. Uh, then you move to the directory, and this is and if so let me okay, so you can extract it. For example, in this case I am extracting it in the download directory itself. Okay. And then what you have to do is, if you want to put it in a different folder, you can always copy it, right? And let's say put it in a different folder. Let's say for me this is downloaded in the download folder. Okay. And it has been so this has been downloaded here, and it has been extracted here in this folder. Then you can actually copy this folder anywhere you want. Okay, so that you can keep it anywhere. And then what you have to do is, from the terminal you open bashrc. Okay. So if you source, then your path, and then bin slash this is root slash bin slash this root.sh. Okay. Then this environment is set, that this particular root, okay, so which is in download folder, this environment is set. And now if you actually type root, you will see that this has been this is already installed. So this is the easiest way. You just download it and then just set the path by this. Okay. And if you want to use it further, then what I suggest is the same command, you write it inside your bashrc file. Okay. So this is what you have to write and save it. I'm not saving it because I have a different version of root that is working already. So I will not be using it. So once you do it, then every time you open a new window, it will automatically, the environment variables will automatically be set, and you can always use it. Okay, so that's the option 4. So option 4. So this is the okay. So that is the setting the environment variable. So this has to be done for option 4 as well as for option 3. So for the option 3, wherever you have installed it, so that is the path that you have given here, the installation path that you have given here, there you will find that bin slash this root dot sh file, and you have to set that path, source that dot sh file. Okay. And option 5 is also another easy option. That is like, if you use Conda, if you are familiar with Conda, then you basically have to create a new environment. I usually don't use Conda, so I'll not be using that. And then you can basically activate this thing. So create environment and also install it by this -c conda force root command. And then once this environment is set, you activate this environment, then you basically can run root. Okay. So that is the thing. So these is for option 3 and option 4. Okay. And then for uproot installation should be easier. If you have Python 3, then you just install pip install uproot, or pip3 install uproot will automatically install uproot. And conda also you can install. Awkward array, that that I kind of did not talk about. So I forgot to write it in this, so I wrote it today only. That can also be installed via pip. So pip install awkward and then conda install. So not then, either this or or this. Okay, so this is also or, this is also or. Actually. So either if you are using conda environment, then use it by conda or in the pip. And then the test is very simple. You go to the shell and try typing root and see if this type of things are coming. Okay, so let's say if I type here root, then I can see that this is a root version 28/12, and what are the GCC versions and all these things, what is my system, all these things that it will show. And so that is the thing. And then if you want to use it within Python, okay, then you have to test this also, Python 3. Okay, and then if you so someone is asking that whether how do I know that this is installed or not. Okay. Okay, so if you actually go here and type import, whether the module can be imported or not, that you can quickly check. Okay, so for example, root has been installed properly. Then if you type uproot, if uproot is installed properly, then if you import it, it will automatically import. And if you want to check that the awkward is installed properly or not, then you import awkward. Okay, so I hope that you are now familiar with this import option in Python, right? So if you have a module, then you can actually import the module by this import option, and import awkward as ak, meaning that this big name that you don't have to use every time you use awkward, you can use ak as a substitute for this awkward. And our data frame, so that you have to also check. Okay, so if our data frame is not installed today, that's fine, because I'm not planning to say anything about our data frame today. It will be it will for the next day, but up to these three we need for today. So any question from this? Our data frame, someone is saying, I think you probably have a version which does not have our data frame, or you did not configure it properly. If you have used it from if you have used option 3, that is like compiled from sources. uh, Import is working, okay, inside Python shell from root import our data frame. That is also fine. This is another correct syntax. I'm also opening it. Did not work, did not work. So you try installing this thing. And Amit, do we have a forum where they can ask questions regarding installations and all these things?
Well, we don't.
Can I make a
Uh,
forum like
the,
Slack channel or something like that?
yeah, I think we need to do that. Yeah.
We need to do that. Yes, yes. Because for the so till now it was not that difficult
Yeah, I mean,
in terms
of
of the
course, the
installation.
so all this installation does can cause some headache. Yeah, this is understandable. So let's do. Yeah, I think it's better to create some Slack or something like that. And
Yes, yes. Okay, so the suggestion is like we will create a channel where, or forum, something like that, and we will share it with you, where you can ask all these installation related questions, even physics related questions also. Uh, so anyway, Yeah, there are many suggestions that people are saying that okay, root file can be converted to. Of course, that is an option. If that is a better RAM management, then you can always do it. But in any case, we will be using root, so we'll not be talking about HDF5. Maybe that is better, but I don't know it. So we'll be talking about root only. So now let me come to the next part. That is introduce you to some of the root files and how to deal these root files or handle data in the root file. Okay. So let me come here. I hope the fonts are big enough to see. Yes. Okay. So root as it has not been introduced to you properly, I think, in this course. I'm also not going to introduce you to like the great gory details of root here. Root is a like kind of a language and interpreter that is very useful, especially in the high energy context. Okay. And so it has actually many use cases, and uh, it has for example, it is very easy to use in the case of data analysis. For example, in the case of high energy physics scenarios where you have event by event data, and for the plots also, for example, histogram, fitting, binning, in case of like selecting events. So it has actually very good interfaces. At the same time, it is very useful in the statistical modeling, and there are like packages, for example, RooFit, RooStat, TMVA, which has been built over root, and it and another important advantage of root is its IO management. That is like your like input and output management, and storing the data in a structured way. Okay. So that is one important advantage that root has, and I will be mainly focusing on this root files, which actually stores our data, high energy physics data, especially the collider data, in a compact form and easy to readable and memory efficient, in a memory efficient and IO compliant way. Okay. But at the same time, root is in some sense platform independent. So that is, you can install it in Linux or Mac OS, and you can use it. So in the earlier days, root used to use with the C++ codes only. But nowadays, what happens that we can actually use root in a Python via Python also. We can access the data files and all these things and all the functionalities via Python. So that is a big step jump that has been done. And what advantage does it give? In the Python, as we know, that it is very user friendly language. So so this language is more like human language, and you can actually use it very easily, and the syntaxes are very like compact and easy to use, rather than C++, where you have to like C++ has its own advantage, like it has it has it it is like a much more faster than Python. But what happens that since root uses C++ at its backend, so what happens that when you call some functions from root or use it, it actually runs in the backend the C++ part, and that's why it is even if it is Python interface, it is actually faster if you use it correctly. Okay. So the C++ part of the root, or how you can code C++ code and run it in root, and C++ macros you can. So that part I will not be talking about. I'll be mostly focusing on the Python interface part of root. Okay. So in the Python interface part, essentially what it does is it gives you the power of the root's performance, which is much faster in the IO data storage and data management case. At the same time, the flexibility Python, which has like very compact notation and quick to use and easy to remember, all this stuff, that flexibility you have. So that is why this PyRoot or like root with Python is nowadays becoming very popular. And the interesting and like thing is that how do you like use the root within Python? This only one command within the Python code. You write import root, import root, in all in cap. You can actually import the whole package within Python, and then you can use its functionalities. Okay, so here I give some of the references. I will share these Jupyter notebook files with you uh, after this lecture. And so the resources mainly, you can go to the documentation page of CERN root that I just opened here. So if you go here in the learn page, then you will see that there are tutorials, and in these tutorials you can actually go and check all many codes. These are in C, but there are like there are codes in Pythons also. If you go to the Python codes, then you can see the Python codes also. So this is a very rich web page where you can actually get many examples of root using Python as well as using C++ language. Okay, so and then PyRoot tutorial, you can actually go to this page and you can check. Let me see if those are, yes, Python interface are there. Then you can actually see and use it. Okay, but I will mostly be focusing on the data handling part, which is via the root files. So root files are basically the files which uses like stores the data in a structured and hierarchical format. So what is this hierarchical format? It basically has mainly three to four elements. So one element is called T file. Okay. So that's basically the file itself where the data is stored. For example, on my left side of the screen, you can see there are like few root files. One is sample1.root, sample2.root, sample3.root. Okay, so these are the root files. So this is the T file, and importing this T file is or opening this T file has this simple command. It's like root.t file open, and then it will automatically all the data and all the object corresponding to that will be stored in F. Okay, and then inside this file you have three main elements. One is like one is called tree. So if you actually are familiar with root, you can see that everything actually in the root, all the data types actually starts with capital T. Okay, so this is this thing, and the next part is essentially the data type. I mean, the whole name is the data type, but this so if you remove the T part, then you can interpret the name very well. So inside, as I was saying, in the file inside this, you have this tree. So which in which many data are stored, and then it's hierarchical, and then within this tree you have branches, and within the branches you have leaves. I will actually go to this example after that. So for example, let me show you one of the examples of this root file, and how you can see these things in a. Okay, so let me go to this same folder where I am in my browser via Jupyter Lab, but it is in the terminal. Okay, so now if you see these files are here. So these are root files. Let us open one of the root file. Okay, sample, let's say sample1 root file. Then if you actually type this t browser, then it will open this window, and you can see that that this file has this structured data. Okay, so this is, as I was saying, that the sample one dot dat is the file itself, and then this data is basically your tree. So you can actually see a sign of tree here, and these are your branches. But so met, for example, is one of the key variables, and let's say uh, in a collision data you have electrons, you have muons, their energies. So in this root file I have actually stored energy of electrons, energy eta direction of electron, phi direction of electron. Pt is basically transverse momentum, which is the px and py component. So uh, that component is stored, and then if you have muon also, the same informations are stored here. And then so you also have a concept of jet in the context of collider. Jet pt, jet eta, and jet phi, all are, and jet mass, all are actually stored here. Although these are branches, I don't see why the branch is not showing here. But I think I have another root file where you can actually uh, see this branch. Let me go to it. This is a different root file. Okay, so here this is the file, and then this is the tree name delphs, and then you can see that there are branches and leaves. Okay, so if you actually look at it closely, you can see the symbol is branch, and this symbol before delphs is actually tree. Okay, so then inside this you can see that the values are actually stored within this leaves. Okay, so even if you sometimes what happens that you can store the data within tree, but you don't need branches to store the data. You can directly store the data. So actually the data are stored in the leaves of the root file. Okay. And for example, in the muon case, you have muon pt, muon eta, muon phi, etc. Those are stored on the leaves. Okay, so here you have an like example where you have tree, branches, and leaves, but on the other example we have only tree and then directly to the leaves. Okay. So these are the things that you can actually see. Okay. Let me now come back. I think there are some questions. Were there any questions? But I guess instruction may have a problem. Okay, where is this? Okay, I'm using Google. Google Colab is fine. Yeah, that's fine. Anything wherever you can actually run these things is fine. No problem. Okay. As I was saying, so that has been shown to some extent here. For example, in my sample one dot root, I have yes, these samples of root files has been created. This I created to give some demonstration here. That's true. And okay. So here this has been shown in a slightly graphical way. So if you have T tree where you have many branches, for example, jet pt, jet eta, electron pt, and etc. And you have the leaves where the actual values of these pts are actually stored. Okay, so for example, jet pt holds values for these in an array. So that's what this is the graphical representation. Now let us come to the coding part, where let us say you open, how do you open a root file in Python? So the syntax that I was like mentioning earlier is very, very simple. It's like you just open. So you have this module that has already been loaded here, and then .t file, this is the file that you're talking about, and then open will automatically open the root file, and that will be mapped to this if variable. Okay, and now let me do it. So this will open it. Okay, and now uh, if we want to see that what are the trees, so there can be many trees inside one single root file. Okay, so what are the trees that that you see? That command is f.list of keys will give you the name of the trees. Okay, so if you actually write name, then you can see that okay, so this directly does not give you the name that we will see, that it will show the object file that it has been uh, copied. But if you go to the, so this will actually give you the list, and then the 0th element and get name will give you the name of the tree. Okay, so which is essentially the name of the tree has been stored with this in this variable. And what is the type of this thing, that is whether this is a T tree or tree branch or something else, that you can get that what is the class name. So that will give you this. Then I just printed that what is the class name. It is tree, and then the name of the tree, okay, is data. So once you get that what is the T tree that you are going to use, then you can load the tree in a separate variable. So that command is basically f, and then f dot get now the name of the tree. Okay, since the name of the tree here is data, but in other example, for example, it was Delphis. So in that case, you had to use Delphis here. Okay, so now if you print this tree, you will see this beautiful thing that it actually shows that what data is stored. Okay, so uh, what is the tree name, that is the data. How many number of entries in this tree there are 50,000 number of entries in this. And then what is the total size, and then it is a memory efficient thing, so it compresses data on its own way. And so this is the uncompressed data size that it says, and then what the compressed data size, that after compression when it stores, what would be the data size that has been given here. And from this ratio you can calculate the compression factor that is also shown. So that is the tree part, and then the branches are also shown here. Okay, so for example, the 0th branch name is essentially MET, and at the same time it says that MET/f means that the data that has been stored here is a float, as a single float that has been stored here. And again, number of entries should be the same, and sizes are same. And this basket actually says that so previous day Amir introduced to the concept of chunks, that meaning that you, if it is a very big file, then you don't like load the data or save the data uh, in a uh, in a single go, right? You make chunks, I mean small portions of the data, and then you store it or use it in this way. The baskets here are actually comparable to those chunks. So here it says that it uses 31 chunks or 31 baskets to store the data, and basket size for each of the basket is this. Okay, and then compression level has also been seen. And then this is the branch 0. Branch 1 is the phi direction of the MET. So the data type that is stored here is actually float, and so number of baskets and all these things. So these are the things. Then you see that branch 3, it says I, meaning that this is an integer. This is an integer that has been stored here. And so this is the number of electron that has been stored here, so that's why it is an integer. And then if you come here, for example, in the branch 6, then it the data type it shows, the branch name it shows is electron, energy of an electron, of the electrons. And the data type it shows that root, vec ops, rvec, float. So this is kind of equivalent to C++ vector, meaning that it's kind of a list, that is not a single number is stored. This, why this is so? This is because in an event, for example, in the HEP collider setup, you may have more than one electrons. Okay, so for each event, you want to store the values of the energies for all the electrons. Like if you have 5 electrons, then you have 5 different energies, and that has to be stored in a list or in an array. Okay. So array is not very good for this case, because array, if we use array, that has a fixed number of entries and it should be a square shape. But if we use vector, then we can have adjustable things. So for example, event 1 might have no electron, event 2 might have 2 electrons, and event 3 might have like 5 electrons. Then in every event it will be different, the size of the size will be different for event by event case, and that is why we need a vector type setup, not an array type setup. So this is that is why this is this. And after this, so electron eta, electron phi, pt, everything are rvec, and rvec, and the contents of this vector, like the elements of this t++ vector or root vectors, are actually floats, that is shown here. Okay, and then the same thing for the jet e, jet energy, jet eta, jet phi, pt, and all these things. Okay, so this structure I think you can understand. Okay, so now if you actually there is another quick command by which you can check what is the name of the tree and file, all these things, and what are the tree names, that is f.ls command. So this is very easy to see that what is the root file that has been loaded and what is the tree that has been loaded. So if it had more than one tree, then it would show more than one tree. Then once you get the tree, then you want to see that what are all the branches that it has. Okay, so then you can actually do it by this command, which essentially gives you the same thing as tree.print command. Okay? So that's the thing. And then let's say you want to use a particular branch. Now let's say you are interested, once the data is stored, now let's say you are interested in one particular branch, for example jetpt branch, which has 50,000 rows, and each row has something in it. So then the command by which you can actually access a particular branch is via tree.get branch, get branch, and then which branch you want to use, you can actually use it. And then from there, what are the leaves that associated that is associated with this branch, that also you can get by this branch.get list of leaves command, and then you can print it. Okay. So so the name of the leaf and the branch is the same here. Okay. So the leaf element is this. Okay. So now if you want to see what are all the branches that you have stored in this, it can be seen, can be done by this. So you get all the get list of branches, and you just basically print the name, and you can also print the class names also if you want. For example, whether this is a T branch or something, it should be T branch. Get class name. Okay, so at the same time it will show that what type of data it stores and all this thing. Okay, so now if you want to, let's see what are the contents of the tree, the 0th element of the tree. Okay, so then so the counting starts from 0 actually. So you can see that it says that it is event 0 and the value of mate. Remember that the mate is a float type variable, so this is a single number, and so the value of the number is this. Mate phi is also another single number. Number of electron is 0. Number of muon in this particular event is 0. Number of jet in this particular event is 10, and all that. But it cannot actually show you the values exactly for this, because these are no longer a single number. It is basically a vector. For that, we have to like do little bit of trick to get it. Now let us see, for example, the first. Let us go from the first event to the second event. Or so in this case, the values are changed. Okay, as usual, electron number still is 0, muon number is 0, jet number is 8 now. And let us see some example where we have at least one. Okay, so this has at least one muon, this stuff. And then if you want to actually see the values of these branches, what it stores, then you have to basically print it accordingly. So printing is easy, that you loop over the events in the tree, and then just whatever the branch name is, you can put a dot and then print it. Okay, so for example, if I want to print the JPT, I'll mostly be concentrating on JPT. Then you can actually print it, and let's say I want to print it for the first 5 events. Okay, so then you can see JPT and Jet eta has been printed. So JPT is an array, or is basically a vector which contains as we remember that 0th or the first event has 10 10 jets. So there will be 10 numbers corresponding to the jet PT. So this is the jet PT in event 0. This is the first PT of the first jet. This is the PT of the second jet, third jet, and so on and so forth. And these are the eta values: eta of the first jet, eta of the second jet, third jet, and so on and so forth. Okay, this is the second event. If we remember that that in the second event, okay, we have 8 jets. Okay, so we have
Sorry, Tousik, there are a couple of questions that you might want.
Okay, let me just finish this part and then.
Sure, yeah.
And this is the thing. So now if you want to, let's say, print the muon E also, muon PT also, that you can actually do. But this has to be event dot PT. Then it shows PT of the muons. Remember, the first event does not have any muon, does not have any muon, does not have any muon. But for this, we have only one muon, so that's now printed. So this way, you can actually print the data here. But one important point that I want to see, that even if it is very powerful, the root, but handling data in this way, that printing and iterating over the loop, is slightly cumbersome. So we can actually, in the next part I will go, that where there are like other packages that you can use, for example uproot, by which you can actually deal these data in a compact way, just like the way the Panda deals with the data. Okay, so you have very compact command and like slicing and all this technique that you can readily use and use the data to manipulate data quickly. So that will be the second part of this lecture. Okay, so this, up to this, we can I wanted to show you that how the data are stored and how to access this data from a root file, and how to like visualize this data after printing it. Okay, so that's the part that I wanted to show here. Now let me go to the question answer, and then we'll break for some time, and then I'll start the second part of the talk. Okay, so collab. So these sample root files that I answered. So Abhinav says T tree data is the 0th tree. How can you know how many trees are there? So that I think you can get it. Let me see. So if you have this thing, okay, let me add a line. How many trees are there? You can actually use the length command. Sorry, and then you can check the length. So it's basically an array, and hence the len command should work. Okay, so you get list of keys, and then you take the length of it. You will get it. And debugger is it possible that the branch has sub branch and then leaves? Sub branch, I have never heard of it, but does it have sub branch? No, I don't think so. I don't think so. Can you explain what these branches are? Okay, so the let me like go here for example. So this data actually is stored in a hierarchical way. Okay, so first you basically let's say you whole data you want to divide in 5 parts. Okay. And then you first define tree, and in this tree you have different components. For example, you want to use that all the properties of different properties of jet. For example, here I can show you an example. Here, okay. So here, for example, it is in a slightly different way of storing data, where let's say all the properties of muon you want to store. Okay, so then what you do is within this tree you create a branch where all the properties of muon will be stored. The branch name is muon, and the properties are stored in different leaves. Okay. So that's the utility of the branch, that you yourself will have to figure out how you want to store the data. So then first the tree, and then you like as do a subcategory, and within this subcategory you want to store different data. So in this case the category subcategory is the muon, and different part of different uh, options for this subcategory, let's say pt, eta, phi, and other variables are stored in different leaves. Okay, so that's the use case of the branch. Let me go to for each tree. The variable event refers to the branches. Here for events in tree, the variable events. What is variable? Right. So that is the iteration over the trees. It's just the last sentence. So this you can call it something else, but so this is the this is the variable for the iteration. Uh, that's why this you can call it something else also. Okay, so this is the iteration over the tree. So in the tree you have 50,000 data, 50,000 rows basically. So you iterate over that.
So those are the 50,000 branches, if I
Sorry,
say. Oh,
there are
so,
not 50,000 branches. Sorry.
okay.
So there are total 50,000 entries, not the branches. Branches are let's say 19 branches. There are 19 branches.
Okay, sir, I got it.
Oh, so which jet is from which event? So the iteration, okay, let me show. So for example, the iteration here, okay. So in this case, iteration is over like in the tree in each event, right? So if it is in the first event, so anything you print, for example, corresponds to the first event. First event has 10 jets. So these number correspond to the first jet of the first event. So these whole 3 lines corresponds to event number 1. So that we can print here also. Let's say event number is count. It's not printing. So I think leave a backslash n. Okay. So first that see event number 0, and then I printed ZPT, Z Muon PT, for example. So these 3 numbers correspond to the first event. And then what is the first jet of the first event is this. What is the PT of the first jet? Eta of the first jet is this. These numbers. So second jet is this. PT of the second jet, PT of the third jet. So this way. So that you can always see that iteration is over the events, and then within the events, then you can have another iterator by which you can actually get the numbers for different jets. Okay. So yeah, I think if we don't have any questions, so we can like break for a moment and then we can start the second part. Amir, are you there?
Yeah, sure. Yeah, we can do
So
that.
when shall we start the next part?
Uh, how about let's say 10 minutes break? Let's say 8 minutes. We meet on 11:10.
11:10. Okay, that's fine.
Yeah.
Hello, Amir, are you there?
Yes, yes. So yeah, I think yeah, you can begin the next step.
Okay, so yeah, maybe this is a good time to start. Okay, let me start then. So let me start with the place I stopped. Okay, so I stopped here. So where I like showed you the hierarchical data structure of root, and then the T branches and leaves structure, and then how to access those numbers in the leaves and the branches that I show. So but just as I mentioned just earlier, that you can access the data and value event by event via loop, right? But that is not a very efficient way of coding, or so maybe efficient way of coding, but coding might take some time. So is there any way that we can easily just like the pandas, that selecting columns or rows or some or all these things quickly and manipulate data and slice it or do something like that, whether it is possible or not? So there is a package called uproot, and if it is like interfaced with awkward array, then we can do all these stuffs. Okay, so that now I am going to show you the power and utility of this thing. So so first show you the um, let me show you the references that this is the, let's say, web page for the uproot, and you can see you can go there and see all these the details of uproot and what are the interfaces and everything that it has. And then the tutorial is somehow not opening. Let me see the, maybe there is some problem with the link that I will fix it maybe. Okay, so let me remove this link and give the main link for now. And awkward array is another interface that I will explain a little bit after that, but the references are given in this. Okay, so that I'll keep here. And then just to, in order to use it, you just have to again before you just have to import it. So import uproot will actually the load the module in the Python environment by this thing, and by this command, and awkward array can also be imported. So for the awkward array, I just put import awkward as AK, meaning that I just keep the shortened name for this. You can directly import awkward, and then if you choose, then you have to use AWK WART every time you want to use it. Okay, so let us first start with the uproot. So just like before, you just have to open the file first. So for example, in the sample1.root that I was showing, if you want to open it, you just have to say open. Uproot.open will open the file. And here also, here one thing is the syntax here is actually simpler than the earlier one. So if you want to see what are the keys it has, you just have to say file dot keys. Okay, so let me put first import uproot, and then if you load it, you can see that the keys here is the data. So that is the T tree that we have. Okay, so that is the thing. And if you have more than one tree inside this, then you will see more than one entries in this list. Okay, so now if you want to use this particular tree, whose name is data, you can actually load the tree just like this, just like a simple Python syntax, file, and this is the tree name basically. So this is file and then tree name. Okay, so that will actually import the tree within this variable, and you can actually see that. And if you print, then it will show that this is a T tree which has 19 branches, as we have seen earlier, and then the location, memory location of this variable. Okay. So then, just like before, you can use the keys method to see what are the branches it has. It has. Okay, so that's you can see that tree.keys actually gives you the name of the branches it has. Okay, so now if you want to, for example, see the, let me show you tree. Let's say you want to see the MET branch, then you just write MET, and you see that it says that this is a branch, name is MET, and the memory location of the branch. Okay. And but this actually does not show you any array, any number for it. So in order to access that, you have what you have just have to do is you have to type dot array method, then it will actually show you the numbers that it contains. So this is first, second, third. So remember that MET was a float type variable, and so it has each event, each entry in the T tree has one single number. So first number is 273.0, and all these things that it is showing. So, and also what is the type it has, it also shows here. Okay. So now MET, then if you want to use MET underscore 5, for example, then it will show the 5 values. Let's say if you want to see the electron number of electrons in each event, then it will electron number, it will show you the numbers here. But if you then want to, so these are simple single numbers like float or integer, but the things becomes little bit complicated when you go to these things. Okay, so then let's say I want to see the energies. Okay, so you can see that first event had only no electrons, so the energy entry is empty, 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 and somewhere it has one electron, so the energy value is 248, another has 491. And if you actually go to jet E or PT, then you will see that it is so first event has 10 entries, second has 8, third has 1 2 3 4 5 entries, and all this. So this array that we are getting now here is a jagged array. It's not a like square or rectangular array that okay, every entry has every particular entry has same number of same numbers in its sub array, right? So in its inner loop. So handling these is slightly difficult and challenging, but thankfully we have one more package or module called awkward array, which can actually easily handle these things. So that I will introduce. But before that, let us see that what are the other ways to. So this is the thing, and then the type of the variable is also shown here. And then if you want to access the full set of arrays in the tree, then you can actually say tree.arrays. It will give you the full array, but I don't want to print all these things because it will be very, very big data. Let me see. Okay. Okay. So it can print it. That's not a problem. So it gives you the details that how many entries are there, and then what are the branch names, and what are the types. So for example, MET, it says that it is a float type, MET5 is another float type, HT is another float type, and number of electron is integer. And then the energy of electron eta phi pt electron are actually vector type, so that is the variable vector type. And then every entry or element in that is a float. Okay, so that it says. Okay, and if you see here, it prints the full. So for the first event, it prints the full thing. So MET, then MET5, HT, and all these things. So now, if you want to only, let's say, print ZPT or MET, then you can do it like this. Or if you want to print, let's say, only the ZPT, you can do it like this. Okay, so then from each event it shows the ZPT, the array of ZPT is this. From the second event ZPT is this, third event ZPT is this. So, and this is the list of PTs of the jets that has been given here. Okay, so that way you can actually see. So this is the example that also has been shown earlier, that you take the ZPT. No, not this one. So this shows the arrays command. Now if you don't want this dictionary type of structure, that is like ZPT colon and all these things, only the arrays, then what you do is for a particular variable you print just array like this, then it will show you the array. So but this remember that this is a jagged array, meaning that it has a different number of uh, different length for different subarrays. So first subarray has 10 elements in it, second has 8, and so on and so forth. But now the powerful thing that it can do is you can now, let's say for example, select only those events with PT or only those jets which has PT greater than, for example, 50 GeV here. So that you can from this jet array. Okay, so then this array you get, and then you can actually select events, just like yesterday as Amir showed, that in the pandas you can give this type of commands to select only those events or only those PTs from a particular set. Okay, so that you can see that now if we actually ask that we need the jets to have at least 50 GVPT, okay, then it only it only prints those jets up to which whose PT is 50 GV. So for example, difference between this and this is that it had 10 elements in the first entry, and once I set that it has to be more than 50, these are stripped off. Okay, so only the first part, only up to here it is given. Let's say if I demand that it has to be more than 200, then you can see that only 2 entries are coming. For the second array, only 4 entries are coming. So on and so forth. So this way, this is a very powerful tool that you can use to select particular events or sets with certain conditions. Right. And so this can further be used in the so now I will go to the awkward array case, where you will have much more flexibility to handle this jagged array. So that is like in every entries, it's not a square array, it's not like every entries in this full list, every sub array does not have the same number of events. So for example, first of all, if you want to do one simple thing, that okay, I have many entries in this, let us flatten this. Okay. So flatten in numpy array, I think you already know that you can flatten numpy array. But this in this case, it is a jagged array. So but the idea is simple, that you just do not have subarrays in it. All the subarray elements you put it in a single array. Okay, then then let's say here it is now 200. Let us say 200. Then and then you put a PT cut on this. Okay, let's say 200 GV, and then you take the mean. So that you can actually do by this. So this I think you understand that flatten means that you take any jagged array and through awkward array and flatten it, meaning that okay, let me show you what it should. Let me send What different? Okay, so now you can see that this sub array part has been removed. It is a single. It is now a single array, which has um, how many entries? So flattened would be, so it has 1,24,839. So this is because every event does not have the same number of jet, and hence some has 2, some has 1 jets. So total of these many jets, where these many jets which has PT above 200 GeV, that has been shown here. Now it also has some advantages. This AK you can do quickly mean and other stuff. Like for example, that if you want the mean of this whole flattened array, you can actually do it very easily. So the mean of this mean of all the jets in the flattened array is 650 GeV. Okay. So now, so this is a very quick thing that you can do, but we might not be interested in the flattened thing, because what in our analysis, what we usually do that, okay, I have some PT, some eta, and some jets, but then I want to select only those events which has certain number of PT, and which should have certain number of jets, certain number of electrons, and all, so on and so forth. So that is one idea that we want to. Okay. Before that, let me show you that if you want to, let's say, take PT at the same time eta, and want to print it, you can actually print it. So just like before, you take the array of the PT and array of the eta, and then you print event by event information, just like before. This is not a big deal. So I wanted to print it for the first 3 events, so that's why this is a minimum of 3. You can print it for the entire set, but I'm not going to do that, because it will print all over the screen. So I just chose three events only. Otherwise, you can, if you want to print it for the whole thing, then you just put range length this thing. So this is a simple Python command that has been used. So just like before, you can now print here that event number 1 has like 10 jets, and what is the PT, what is the eta, that you can print. And just like before, you can actually print if you want muon PT, muon eta, muon energy, everything that you can actually print. So this is this is another. Then in the awkward array that that you have, that how many arguments this array has, that can be seen from this argmin command. So it says that, so this is not the number of jets, but it is the argument up to which the sub array goes to. So for example, for the first event, we need know that the jet PT array has so jet PT has 10 numbers. So argmin will basically give you 0 to 9. So total index would be 9. So 9 here. A second event has 8 jets. So the argument it goes is the index it goes to is 7. So that's why this is 7. And that's how this is another thing that you can use, especially when you want to loop over the events, that how many you want to print, how many you don't want to print, and so that way you can actually do it via this argmin command. Okay, and then another interesting part, that let's say if you have this PT and all these things, but now all this PT you want to order it in a ascending or descending order. Let's say you want to order it um, in a so this is already in a descending order. Let me show you what you can do if you want to use it, let's say in an ascending order. So So earlier it was like first jet was 1.19 times 10 to the power 3, and then so on and so forth. But now we can actually sort it. The every subarray will be sorted according to their PT. And then if you want to use, so this particular event set already has a sorted PT ordering. But let's say if you want to sort it in a different array, then you can do it. And then if you want to use it in a descending order, meaning that the leading PT will be the first element, zeroth element, then the subleading, and so on and so forth. Then you have to say ascending to be false. Then it will be in a descending order. So it was already in a descending order, so it will show you the same thing. So this you can use for other arrays also. Okay, I think there is a question. Let me see. Yes, I will share the root file also. Okay, so now the part that okay, so the second part that I wanted to show, now let's say we want to select the events which has PT greater than 30, or let's say make it 50 now, for example. It's 30 will be very very small, or and and we should so every event should have jets with at least 2 jets with PT greater than 50. Okay, so if that is the condition, and how do you do it? Okay. So in the earlier case, what we did is in this case, what we did, we just printed here, for example, in this, what we did is we put the PT card, that's fine, but only on the PT array. Okay, now what we want to do is we want to take those events and all the event on all the other variables from that those from only from those events which has PT greater than a certain value. So that is a slightly trickier part, that we are not extracting one particular array, we are extracting different arrays and then putting the PT cut only on one variable. Okay, so let us see how we can do it. Okay, so first I have what I have done is I have defined a variable called jet over 50. So earlier it was 30. So 50 variable. So this is a basically this condition is a Boolean condition. So this variable is a Boolean variable. So either it has a true or false value, and then what we do is we put this condition inside the jetpt array. Okay? So this is the thing, and then we say that those events we want to select should have greater or equal to 2 jets. Okay, so that is the condition we give, and on the jetpt array we select only those events. So this particular example is the starting point, but it still has the jetpt array only, just to show you the case that we can first combine this and then this thing to the jetpt array, then we'll go to the event selection part. So first we put the condition that if the jet will just select from the jet array which has PT greater than 50 GeV. So that you say that we can set in this number, and and then number of the jets via this number method, ak.number method, is stored here. And then we put the selection criteria on this number of jets which has 50 GeV or so, and then we say that this is a different Boolean variable, and with this variable we are trying to select jets. Okay, so this actually shows you the number of the jet PT array which has 50 so which has at least 2 jets with PT greater than 50 GeV. Okay, so now if we want to say that it has to be 500, let's say, then you see uh, this is somehow not working. PT. This should. Let's see what's not working. Jets over 50 jet PT array. 50 jet PT array. Okay, somehow it is not working. It is showing all the jets, right? Okay, let me go to the next example. Okay. But this is working. Somehow that is not working. Why is it not working? But this number is working. In jets over 50 greater equals to, you can split 2 good jets. Somehow it is not working. Anyway, so let me go to the second next part, where I have now selected only those columns, those variables, let's say of my interest, PT, eta, phi, and m, only those variables into an array. Okay, and then that can also be done, and library that has been used is the awkward array library. And let me so this is the thing, and then you can actually from this array, you if you want to choose the jetpt array, you can take the jetpt thing, and then if you want the jet eta, then you can actually use the jet eta thing. Then you can actually if you want to print them, you can actually print them. And then in these arrays, just like before, I can actually select only few of the things. Let's say eta, MET, and eta of electron, and all these things I am not selecting. I can only subselect a part of it. The tree dot arrays that we already have seen that we can use it, but if we do not give anything here, it will select all the columns. But if we want to select only particular some particular branches, then we can give it via this command. So now the arrays actually stores only these columns. Okay. So if you actually now print these arrays, you can see that only these columns are there. Okay. Now, the earlier command did not work, but let me see if this works. Okay, so here also is the same thing, that okay, I want my jetpt to be more than 50 GB. So that I can select, and then I have already selected this within these arrays the interested variables in which I mean the variables in which we are interested in. So that has been selected. Now this mask. So this is the same as before. That it only selects those JPT which those jets which has PT greater than 50. Okay, and then let's say I want my number of such jet to be less than greater than, let's say, 2. Okay, then I can actually select the jets having that PT. So selected PT, I can see that. Okay, so now this is not, this is also not working somehow at this moment. I don't know, this should work. Oh, I see. No. This is fine. This is fine. I was interpreting it wrong. So this is the set of events. It is printing the whole jet array. That's fine. That it should do, because this is the event which has at least two jets having PT more than uh, uh, more than 50G. But I'm not selecting only those events, so only those jets. So that we can do it later, but it has jets which has PT greater, at least two jets which has PT greater. So it will show the entire event, entire thing. Okay. But for example, if we make it, let's say, um, yeah, I was interpreting it wrong this time. So let's say I have, so let's say for example, if I make it more than 550, okay, then such jet should be greater than 2, then you can see that it is not printing the first event. It is starting from the second event. Okay, because first event, if you remember, does not have jets having PT more than 550 GeV. Okay, because the second jet is 544. Okay, so this event will not be selected. So that event is getting dropped, but once it is selected, the event is selected, it will print all the things from it. Okay, so that is the interpretation. I was interpreting it wrong. Okay, so that way, this way you can actually select those events, and then whatever you want to do with these PTs and all these things, that you can do. Okay. So then I will show one small simple example where you can use this and create a pandas data frame that was introduced yesterday. Okay. So to do that, we want to use a particular command called pad nan command. This command actually says that let's say I want so as you know that in the pandas data frame, it cannot support the jagged array thing. Okay, so it has to be always rectangular array. So let's say I want my data to be at least 5 jet. So I should have 5 entries corresponding to this. But jets to be, let's say, at least 5. But it might happen that I have event where I don't have 5 jets. Okay, so then we have to, just like yesterday that Amir introduced, we have to give some filler for the empty part. Okay, so that's where this pad none comes in, that if there is, let's say, less than the required number of jets, then you fill it with none. Okay. And how many jets you want, that is given here. And so let me show you in this example that I want at least one jet PT jet, and having PT. So this is not selected, so at least one jet. So then it will give you a data frame, and then with that head command, we can actually see what is the PT value and this actually says that 0th element I am taking. Okay, so now if we say, let's say I want my event to have I want 10th jet. Okay, so I have to have 10 here and then 9 here. Then you can see that so first event has 10 jets, so last jet it can print. Okay, but second jet does not have 10th jet, so it does not have anything. So it actually the filler here is actually nan, so it will show nan. So right, so that's the that way you can actually do it. Okay, so this is the 10th jet, that if you want to select 10th jet, if you want to select, let's say, 7th number of jet, so then so this can be 10, this is not a problem, this is like this thing, but this you have to be, let's say, 7th, for the 7th jet it has to be 7. Okay, so now you can see that in those events where you don't have 7th jet, it is filled with nan. Okay. So this is an useful tool to convert your data, like the jagged array data, into your pandas data frame or numpy data frame. So here the example that I showed here is, first it fills wherever there is nothing with nan, and then we can select which column to which particular data to use, and we then convert it into numpy array, and then we can like uh, do that. So you can use eta electrons and other things also, so that's not a problem. Let's say, let me see that if we can have, no, this is not working. So the pandas, it has to be simple data structure, so that's fine. So the power is basically that you can quickly read the root files in the which is stored in hierarchical T tree, T branch, and T leaf structure, and then you can so in high energy experiment, usually the array that you get is a jagged array. Then with the awkward array, what you can do, you can convert this jagged array if you want to a square array of your choice, or you can quickly select it, and you can actually convert it into a data frame, pandas data frame, which can later you can use it for plotting or whatever things you want to do. So this is the power of awkward array, and or you can convert it into numpy and other things. So that is the thing. So this is one way to handle let's say the data via uproot and awkward array. I will show you in the next class. I will show you how you can handle data using another data frame which is inbuilt in the root, which is called R data frame. So that R data frame I will start from tomorrow, and so not tomorrow, day after tomorrow, I will show that that also is a very powerful tool, and you can always once it is in Python, you can always integrate it to some other Python things, especially in the ML context. Once you manipulate all this data, you can then send it to the machine learning as an input, or you can convert it into pandas, or you can convert it into torch tensor, or you, which will be, I think, used later on in the ML courses, and or you can convert it into numpy arrays, or and then plot it, whatever you want to do. But that is the thing. So in this basically lecture, it is essentially that how you can read the data and see it, visualize it in the root example that we saw. But in this basic root version, handling the data is not very useful, and that's why we take help from uproot and awkward array, just to handle the data in an efficient way, and efficient coding as well as efficient memory management and management way. And then we see that okay, we can actually convert it into different data frame. So that is what we learned. And the R data frame, which is another powerful tool, and where you can actually do all these selections and filtering, and where you can actually define new variables also from the old variables, and in a very efficient and quick way, that we will see in the next lecture. So I'll stop from now and I'll go for question answer. Let me see. Okay, so can you get this root file? Yes, that is answered. But ptcut is not working. I don't know why it is not working. So is ZPT the number of entries in the jet array? ZPT basically contains, let me show you here, for example, ZPT here, right? Yes, ZPT. So so these are, let's say this is the first event, this corresponds to the second event, this corresponds to the third event. Okay, and ZPT contains the PT of all the jets in an array. Okay, so this ZPT, for example, for the first event, it has 10 jets, so there will be 10 entries here. Okay, so JPT is an array where you store the PTs of all the jets in an event. Bob is saying, what if we meant to point the jets with only PT greater than 500, not all? Okay, so that I think I have discussed that 550, whatever choice you have, you give this here, and you can actually select only those jets. And from, so I don't know what your question is, but if you want, uh, I think this is asked when this was, I was explaining this part. Okay, so this is these. I think this you are saying then. I want. So this is the selection of the events, but it is showing at the moment all the jet, all the PTs, all of the PTs. But then again, we want to select greater than 550 dB. So then the answer is simple here. Uh, uh, then once you get the selected events, okay, then you put the condition 550 again, then you will get this thing. Okay. So once the events are selected, now it contains a PT of the selected events. All the PTs here, but then again you want to put this type of condition, you can always put it. Okay. Event mask portion. What do we mean by flatten variable? Flatten is very, very simple. Flatten is like you have this full array, for example, and this array has sub arrays. It's basically not an array, it's list. List, and then you have sub list inside. And flatten is basically removing this sub list variable, meaning that you just take all the values in a single list. So that's the idea of flatten. Like it is printing. Yes, I think I have explained it. Can you please explain event mask portion? Event. Oh, event mask is, this is a variable, that's not a problem. So event mask, so this is the condition that we are putting, right? So first we selected, so although the name is a little bit incorrect now, first we selected that PT has to be greater than 550 GB. So that gives already that gives that only those jets where PT is 500, and then with this num function, we uh, basically collect from each of the event that how many of such jets exist. Okay. So from the first event, if you see, only one event exists, one jet exists. From the second event, 3 jets exist with this condition. So this is the second portion. Then you put condition on this new variable. So this is kind of a new variable. On this variable, you put the condition that only it has to be greater than 2. So then so those event will be selected which has this event this condition, which meets this condition, this criteria. Okay. So that's the idea. Okay. I don't see any more questions. I think I'm done for today. The quizzes and will be given in the next session. Yes, I will share the notebooks with the organizers, and then it will be uploaded, I think.
Okay, then I think this would conclude today's session.
Mhm.
Yes. So thank you, Tousik.
Yeah, thank you all
So,
for attending.
so
Okay,
we'll
so Amir,
continue
we have
maybe.
to, yeah, so
Yeah,
we
yeah.
have to
What?
maybe create a Slack channel or something like that.
Yes, yeah, I believe so. For especially for all these installations,
Right, right.
that is, yeah. Yeah, I think what we can do is we create a Slack channel and we send the link via of this. I think we have the email address of all
Email
this guy.
address, or we can upload, I mean, link it in the web page also.
Yes, I think that would be great. Yeah, in the website, if we can do that. Yeah. So, okay, guys, thank you for today.
Okay, thank you.
Bye.